So the week one chapter is pretty dense. There's some general topics about geography and kind of understanding how geographers look at things, and then there's a lot about some of the tools. So I'm going to do this in two videos, and so the first one will be pretty short. One of the things that the reading talks about is that when we're looking at physical geography, we're looking at location of things, but we're also looking at the form features take and the process that creates them. So things like how can you identify an earthquake fault from an erosional landscape? What causes earthquakes? What other landforms can be created when you have an earthquake? And so being able to understand those aspects of landforms. So looking at river processes and how they move and how they transport material and why they happen in certain areas, and different rivers take on different forms. We'll see later that there are meandering rivers that curve around, and there are rivers that are very fast and straight. And this all depends on where they're located and what kind of geography they're running through. So there's a lot of aspects in physical geography. We're also going to look at the spatial perspective. We want to know where things are, why they're there, and why people care about them. Another aspect of physical geography, if it's done well, is that interaction between humans and the environment. So we'll use that a lot in the term, and I like to bring in kind of natural disasters just because I think they're engaging and they're important. What you're looking at in this class is this blue section. So you're taking some very detailed aspects of physical geography, and we've kind of jumped them all into one intro level class. And sometimes this is more difficult than an upper division class because there's a lot of terms, there's a lot of new ideas and new concepts. And so there's some rote memorization in this class as well. Physical geography is on a continuum with human geography. It all covers the whole geography discipline, and we're going to be looking at kind of the astronomy, looking at the location of the Earth with respect to the Sun and how that impacts us. Then we'll look at more of the specific landforms and climate types as we go through the term. Just a reminder how the class will work. There's an introduction at the beginning of the topic. I would take notes on the any PowerPoints that I give, and then open up the quiz or the study guides and go through that while you scan the reading and watch the embedded videos and take notes while you're doing that. Then if there's an activity that week and directions, go through that, and then you can study and take the chapter quiz and turn in your activity. Now remember, the quiz is open book, open note, so if you've actually answered all of the study guide questions, you should be able to put away any of the reading and just work from your study guide, and you can copy and paste into Moodle. Again, you have to copy with keystrokes, so control on a PC, it's Control C to copy and Control V to paste. So when we talk about a spatial science, there's kind of three aspects that we're considering. One is basically location, where events happen and where those features are. Then we want to talk about why they're in that place. Is it just a fluke? Do you find this pattern commonly across the globe? And then the interaction is, why do we care about that? If we know where an earthquake has happened, can we predict future earthquakes? Can we understand and prepare better for our existence? So some elements of spatial thinking are location, and we can look at relative or absolute location. And I'll talk more about that in the tools section, but relative location you use all the time. You give people directions to one place based on the location of a known or other feature. So my house is 3 miles south of Spencer Butte. And so you give it relative to another location. I wouldn't use right and left because that really depends on which way one is facing. So we'll use cardinal directions, north, south, east, and west. The other element of spatial thinking is this idea of spatial patterns. So the arrangements of features. When you look at the Cascade Range and the Rockies, they're very linear north to south. So why is that? And is there a cause for that? Why do some streams have a meandering pattern and some streams have a very what's called a trellis pattern? They look like grape trellises. The other third aspect is that spatial interaction. Again, the cause and effect, and how a flood can cause more flooding, or how wind erosion can create further wind erosion or could stop wind erosion. So one of the things that in looking at cause and effect is to think about the rain shadow, and this is the image from your text, but I really want to talk about the Oregon situation, which is quite similar. We have an ocean to the west. We have a range of mountains very near the Oregon coast. Then we have the Willamette Valley, and then we have a higher range of mountains. So we have a little bit more space between the coastal range and the Cascade Range. And so, what caused those mountain ranges? Well, both of those mountain ranges are caused as a result of the ocean crust sinking down below the continental crust. And when this happens, it's generated two different types of mountains. One type of mountain is from uplift and folding. That's the coastal mountains. And then the Cascade Mountains are a result of volcanic activity. So then the effect of those mountain ranges continue as you look at a lot more rain along the coast, and then the rain clouds kind of move up over that coastal range, and there's less precipitation in the valley. And then as those rain clouds or whatever clouds are left move up over the Cascades, they completely lose all of their precipitation. And on the east side of the Cascades, we have deserts. So this is a cause and effect aspect of the location of those mountains and understanding their form and process. And then you can predict that and see that in other places around the world. A major aspect of this chapter and part of the first activity will be the scientific method. And so the scientific method is applied in geography, physical geography probably more commonly, but it's a systematic approach to problem solving. And you'll see this outlined in different ways. The steps can be a circular. The book has a few different step orders than I've written here, but basically, you begin by observing things. You might take notes, you might sketch something, you might measure something, or you might kind of watch something over time and say, whoa, what's going on here? And then you come up with a hypothesis. Gosh, I think for some reason those mountains are causing it to rain. Maybe you don't know about adiabatic effects, and so just for an example. And so then you kind of develop a hypothesis. So what could be causing that? And then you develop some methods for testing that, which require more data collection, more observations, and then you can go into analysis and conclusion, and you test your hypothesis. It may or may not be true, and you go back to more observations. So the first activity will walk you through that. So make sure to watch the second video that talks about tools and latitude, longitude, about scale, and I think there's some mapping aspects of that as well.